Okay, so last day we have been discussing about the basic Hello World program in ROS. Okay, we didn't discuss the code, but what we have done was we ran actually the Hello World, that the talker and listener, and then we have worked with some of the important ROS command line tools, which is ROS node, ROS topic, then ROS message, ROS service, all this stuff. Okay, so I hope you got some understanding, basic understanding about how the nodes work. I mean, how they are communicating, how to visualize the computational graph, how to check the list of topics, list of surveys, nodes, how to interact with nodes, all this stuff. So, today we are going to discuss the last topic of the first chapter of ROS 1, which is ROS Turtle Sim. Okay, so why I included this topic was the Turtle Sim is actually a tool. Okay, it's basically a 2D simulator, and which is actually designed for learning ROS concept or practicing ROS concept. Okay, so if you have ROS installation, I mean, if you have Ubuntu and ROS, then you can simply, I mean, practice along with me, or you can maybe watch later. Okay, so basically, in order to start with Turtle Sim, I mean, the Turtle Sim, the simulator is actually there along with the ROS desktop full installation. So when you install ROS, that means the Turtle Sim is already installed on your computer. So in order to learn about Turtle Sim, just search about Turtle Sim ROS. Okay, Turtle Sim ROS, and you will get the wiki page of Turtle Sim, and I'm sharing the link. So there are some commands in order to start with Turtle Sim. I hope you can able to see it. Okay, so this is the command to start with start the Turtle Sim. Okay, so this is the Turtle Sim simulator that I'm talking about. Okay, basically the simulator is a 2D simulator, and there is a turtle on the center, right? So basically that is a robot. Okay, for a mobile robot or a wheeled robot, in order to move the robot, we have to give linear and angular velocity. Okay, linear velocity, if you give linear velocity, it will move forward, and if you give angular velocity, it will rotate. And if you can give linear and angular velocity, it will be moving in a circular shape or something. Okay, so why they included this package and this node? Why? Because the Turtle Sim node basically publishing certain topics, and it's subscribing some topics. Okay, and also it is providing some services. Okay, and also it is having some parameters. Okay, so what it means is that this node is having almost all the concepts of ROS implemented. Okay, other than ROS action. Okay, so if you have a node which is having all these ROS features, I mean ROS communication, I mean methods like topics, services, all this stuff, then you can simply practice it. You can call it, you can list it out. Okay, so that is what the intention is. Okay, so just a sec. So in order to start the Turtle Sim, okay, it's very easy to start. Basically, you can first start the ROS core. Obviously, that is the first command that we have to execute for running any node. So ROS core, okay. And after starting ROS core, what you have to do is you have to use ROS run. I think you may remember the ROS run is for running a ROS executable. Okay, so ROS run space the package name. Okay, so the ROS run command is already here. Okay, so maybe you can simply copy paste, or like you can type it. So there is a package called Turtle Sim. It's already there when you install ROS. So you can simply type ROS run Turtle Sim, and if you press tab twice, then you can see the nodes inside this package. And what we need is the turtle sim node. Okay, turtle sim node. So this is a command to start this 2D simulator. Okay, I hope that is clear to you. And if you just press enter, you can see this blue window. Okay, and this is actually a roast node. Okay, this is a roast node. Roast node can be anything. It can be like command line based node, or it can be a GUI. In any program which is having the ROS API can be considered as a roast node. Okay, so the turtle sim is a node, and as I mentioned, it is publishing, subscribing, creating services, and reading parameters, all these things. So what is the first step? What is the first step to understand turtle sim? Okay, we have a tons of command, right? We have tons of command to understand this node. Okay, so first I will try, maybe we can start with some command line tools. Okay, so I'm taking a new terminal, and then I'm just putting the terminal on the left and turtle sim on the right. Okay, otherwise what happening is that, like, if I put the terminal and if I put the turtle sim, in order to access the terminal, if I press the mouse, then turtle sim will go on the back. Okay, so it will be better to keep like this. Okay, when you work with turtle sim, in order to see what is going on in the simulator, you can keep like this. Okay, I think that will be good. Okay, so now let me try to find what are the nodes currently running. Okay, so I'm using rows node space list. Okay, so what is the output that we got? The output is the turtle sim. Okay, and also we have the rows out, which is coming from the rows master, I mean rows core, basically for the logging. But we get to know about the turtle sim node, so that is actually running. And what is the command for getting the information of this node? We can simply type rows node space info turtle sim. Okay, so when you type it, okay, when you type this command, you can able to see the node name, then the publication, what are the topic it's going to publish. Okay, what is the topic it is subscribing, and what are the services it is giving. Okay, you can check this much, I mean this much. Okay, these two, the last two is actually for logging. Okay, we don't need to consider that. Okay, so these are the topics that is publishing and subscribing. Okay, so can we check the topics that is publishing by the turtle sim? Okay, because it's publishing, right? It's keep on publishing. So there are two topics, that is turtle1 pose and turtle1 color sensor. Okay, so in order to view this topic, okay, view the data of this topic, what do you have to do? You have to subscribe it, right, somehow. So one of the easiest method to echo the data coming from the topic is rows topic echo. Okay, rows topic is the command line tool, and echo is the command for subscribing the topic. Okay, and then printing the content. Okay, so if I do that, then you can see what is the data that we are getting. Okay, the data is x, y, theta. Okay, and linear and angular velocity. Okay, so this is what turtle sim is publishing. This is one topic that the turtle sim is publishing. Okay, and what is this? This is actually the pose of the turtle. Pose of the turtle mean, where is the turtle now? Currently it's on the sender, right? Currently it's on the sender. So I think this is the corner basically. Okay, this or this. Okay, so this is 0 0, top left, I guess, top left, and this is around 5.5. Okay, total is I think 10. Okay, so that is x and y. Okay, so the turtle is in the center, and the theta is like it is 0. Theta means the rotation. Okay, so if it is rotating, then the theta value will change. Okay, and the linear and angular velocity, if the robot is moving, then it will have some velocity associated. If it is moving straight, then there will be a linear velocity, and if it is rotating, it will have angular velocity. Okay, so this is what the turtle 1 pose is. Okay, and you may note that it is turtle 1 pose. Okay, so this is the pose of the first turtle. Okay, and this is a simulator. We can add any number of turtles. Okay, any number of robots. So based on the if you create a new turtle, then you will get additional topic called turtle2/pose. Okay, like that you can create any number of turtle. Okay, then only then from this topic you will get the pose of each turtles. Okay, I will show that. So just understand the topic it's publishing. Okay, and what is the other topic it is publishing? It is color sensor. Okay, there is a topic called color sensor, and let's see what is the use of this sensor. So we can simply echo it, and you can see there is an RGB value is printing. Okay, so what happening is that this is not a normal robot. I mean, just moving, or it is having some functionality. Okay, first functionality is it is having a color detector sensor. So it can detect the color under the robot. Okay, and also it is having a pencil. So whenever the robot move, there is a pen. So whenever the robot move, the pen also move, and it is literally drawing it. Okay, so if you move the robot in a circular way, you can see a circle because the pen is actually drawing it. Okay, so the color sensor and the pen is there, and the color sensor value can be obtained from the topic. Okay, so these are the topics that TurtleSim is publishing. Okay, and the next question is, what are the topics that is subscribing? Okay, so it is subscribing a topic called command velocity. Okay, so can you say what is this command velocity? The TurtleSim is actually subscribing it. It's actually receiving this topic. So can anyone say what is this command velocity and what is the use? Anyone tried TurtleSim before? I think some of you are already know ROS basics, right? So anyone tried TurtleSim, and do you know what is command velocity? Turtle1 command velocity. Okay, maybe I can explain. So command velocity is actually the input. Okay, Tarun saying coordinate for the robot to move to a position. Tarun, there is a difference. Actually, that is not the command velocity. That there is a service for moving to that position, but this is the linear and angular velocity. Okay, because the input of the robot is the velocity commands. Okay, so when you publish a linear velocity to this topic, then what happened? The robot will move. If you provide an angular velocity to this topic, if you just publish an angular velocity to this topic, then what will happen? It will rotate. Okay, so we can simply check it. Okay, so this is what the TurtleSim is subscribing, right? So what you have to do is we can simply publish it. Okay, we can simply publish a data to this topic. Okay, basically this command velocity is the ROS message is twist. It is from geometry messages. Okay, yesterday I have shown you different standard ROS message packages. One is geometry message. Inside that there is a very popular message called twist. Okay, and this is what we are using for any mobile robot. Okay, if you are working with gazebo, if you are working with stage and player, mostly in order to give linear and angular velocity, we will be using which message? Geometry message / twist. Very important. And that is also what the turtle sim using. Okay, so when you work with the turtle sim, you will get an understanding like how to work with a robot in gazebo. Okay, you will gradually get it. Okay, so after putting the message, I'm typing tab, then I can see the content of the geometry message. So if you want to understand about geometry message twist, what you have to do is you can use which command? Rows MSG. Rows MSG show geometry twist. So you can able to see it is having linear and angular field. Okay, so this is the two field. Okay, and you have to assign the linear velocity to the linear variable and angular velocity to the angular variable inside the message. Okay, so these messages are like struct. Okay, I think you have heard about C struct, or maybe you can consider like an object as well. So maybe during programming you will understand that. I'm not confusing you now. So basically it is having linear and angular variable, just understand. And then what you have to do is you have to give maybe linear or angular velocity. Maybe I'm just giving 0.1. Okay, angular velocity. And then what is the next argument? You have to publish this at some specific rate. Okay, so I'm just publishing it at 1 head. That is what showing -r space 1. And now you can see the turtle is gradually moving. You can see it's rotating. Okay, so you are literally moving a robot. Okay, if it is a rows based robot, both in hardware or in simulation, in order to move the robot, what we are providing? We are providing the linear and angular velocity. And which message that we are using? It's geometry message twist. Okay, so this is how we can publish the twist message. Okay, so this is through the rows commands, but when we start with the programming, you are literally writing a program to publish a data to this topic. Okay, so while programming, we can see how to publish, subscribe, all this stuff in program. Okay, in programming. So this is what happening, and then I'm just press Control C, and then I'm just publishing it a higher rate and see what happened. It's the result is same, but now I'm planning to like increase the velocity is set to 1. Okay, 1 radian per second, and then it got faster. Okay, so you can't able to see the pen, right? The pen is not visible. So in order to visualize the pen, I'm also giving some a linear velocity. Okay, so guys, actually this is a 2D plane, right? 2D plane. So only the x component of the linear velocity will be there. Okay, and this is a differential drive robot, like it can't move in y direction. I mean only x direction, and in order to move in a different angle, it had to rotate and move. Okay, so it is not like omni wheel or omni omni wheel robot that can move in x y direction. I think you may have seen this omni wheel robot. So this kind of robot can move in x and y plane, but this robot is actually a differential drive robot. It can only move in x direction. Okay, so if I'm giving both value, maybe I can just reduce the angular velocity a little, and then you can see it's moving in a circular shape. Okay, so linear and angular velocity, it's moving in a circular shape. Okay, and you can see the pen, right? The pen color is now white. Okay, so it is moving at a very slow speed. I mean, even if it is the visualization is a turtle, so you may have question why they use turtle everywhere. Okay, so why? Because turtle is the logo of ROSE. Okay, ROSE actually using turtle as the logo, and you can see turtle everywhere. And there is another thing. There is a programming language called Logo. Okay, don't confuse with that ROSE logo. So I'm not sure you have seen this logo programming. It is actually training in high schools. So in Logo also, the turtle is actually the like the turtle sim is very similar to the logo. Like, you can write your program on the left side and you can execute, and the turtle will execute it, like forward, rotate, all those stuff. Okay, so I will say the turtle sim is like the logo programming in ROSE. Okay, so you can see it is moving in circle. Okay, I'm just pressing Control C. Okay, so what we have done was we have subscribe to the turtle sim topics, and also we have published a topic called turtle1 command velocity, which will be subscribing by turtle sim. So if you have any confusion, I can show you the computational graph using the RQT underscore graph. Okay, so so if you have any question, you can either type in our DLP discussion channel, or you can just unmute and ask. Okay, so here you can able to find the ROSE topic command. Command is actually a node. Okay, so when you run ROSE topic, it will become a node, and that is actually publishing command velocity, and that is subscribing by turtle sim. Okay, so this is what happening now. Okay, and yeah, so the turtle is keep on moving, and now can we echo the pose of the robot? Okay, so I'm interested to see what is going on the pose of the robot. So I'm just echoing the topic called turtle1 pose. Okay, and then you can see the pose of the robot is actually changing. Okay, so the robot is moving, and the pose, XY pose, you can see XY and theta value is keep on changing. Okay, so this is actually the topic that is publishing by the turtle sim, and this is actually giving the giving the feedback of the robot. And you can also see the linear and angular velocity. What is the value? It's 0.1. Okay, so if we increase the linear velocity for say 1.1, you can see the linear velocity change into 1.1, and angular velocity is 0.1. Okay, so now the robot actually hit the wall, and you can able to see the turtle sim node terminal. Oh no, I hit the wall. Okay, so this is the message. So it's actually hit the wall, so we can simply like close it. Okay, and yeah, so currently you can able to see the turtle sim is here. I mean, turtle is here. So basically this is X is 0 and Y is 9. Okay, so that is a position. So mostly this is actually 0 0. Okay, maybe I can show you another thing. So currently we have just published the command velocity and then echo the position of the turtle. Now we can do a teleoperation. Teleoperation means just moving the turtle using the keyboard. So whenever you press the keyboard arrow keys, that node will convert that key press into command velocity. Okay, so then the robot will move like that. So there is a teleop node present in the turtle sim package. So in order to take this, you can take turtle sim and then turtle underscore teleop key. Okay, now I can use the arrow keys, and then you can able to see the robot is moving. Okay, it's like a game. Okay, so you can able to see. So currently, see, okay, so this position basically 11 11. Okay, the corner. Okay, just a second. And if you move the robot to here, okay, so actually I was wrong, I guess. So this is actually the starting point. You can see the current position of the robot here. Okay, bottom left is the 0 0. Okay, so if you just go up, then the Y value. So this axis is Y. Okay, and this axis is X. Okay, you can see the X values increasing. Okay, so if we move to this point, it is like 11 and 11. 11 is the maximum pose, and if you move to this point, let's see, it is like 0 0 11. Okay, so these are the coordinates of the turtle sim. So basically it is starting from bottom left. Okay, bottom left. I mean the 0 0 is bottom left, and the center is 5 5. Okay, I think you got the point, right? Okay, so we have played with the turtle teleop key, and maybe we can check the RQT graph, what is going on with the teleop key. So you can able to see currently the teleop turtle is publishing a topic called command velocity that is subscribing by turtle sim, and the turtle sim pose is actually echoing. Okay, so this is what happening now. Okay, so I think interpreting the computation graph is very important, because currently there is only 3 nodes. Okay, but in a complex robot it will be like 20 or 30 nodes running simultaneously. So you have to understand how the communication is going from the computation graph. Okay, so now we are going to see the row service in turtle sim. Okay, so in order to check that, I am still not closing the teleop key. Okay, teleop key I'm not closing, but in a new terminal I'm just listing the services. Okay, using row service list, you can able to list out the services. Okay, so there are many services providing by the turtle sim. So we have clear, kill, reset, and these all are loggers. Then spawn, then teleop turtle, oh this is again logs, and set pen, turtle port absolute, turtle port relative. Okay, so there are many services, and all the services you can actually see here what is the purpose of these topics or the service. Okay, you can see here there is a service called set pen, which is actually for changing the pen color. Okay, there is a service called clear, which is clearing the turtle sim background. There is reset, which is resetting the turtle sim and just resetting into the start position. There is a kill, which is kills a turtle by name. Okay, you can kill, I think if there is multiple turtle, you can kill one. I think the spawn is for spawning an additional turtle. Okay, so we can simply practice it and we can simply see the parameters. Okay, so these two things we can see. After that we can go to the workspace and packages. Okay, so let's see first with the clear. Okay, so in order to call the services from the command line, okay, what you have to do is you can use the row service command, and then in row service there is a argument called call. Okay, so that is what we are going to use. Row service call, then mention the service name and then press tab. So the clear, which is just a second, you can just first get the service info of clear. So clear is actually a type called empty. Okay, so we have seen rows messages, right? Rows messages, so which is the type of data going through the topic. Okay, we have rows services as well. Okay, rows service type. Okay, so the row service is like I already explained to you. The row service is like request and response, right? So there is a type associated with it for request and the response. Okay, so there is some standard services available in rows, which are these services. Okay, standard services. Okay, so these are some of the existing services available. There is empty, set bool, trigger. Okay, so these are some standard services. So empty means there is no request, there is no response. It will send a null request and the service will not send anything. That will be also null. So it's just triggering. Okay, just an empty request. And there is a bool request, which is like request is some boolean operation. Okay, it is for enabling and disabling. You can see the example. So if you want to switch on or turn on some lamps in the robot, you can just send bool data 1. Then if it will send to the server, and if it is success, you will get bool sucks and with a message. And this is trigger. So there is no request. There is no request type, only the response type. Okay, so we can simply call this kind of service and then it will give with a response. Okay, it is almost all for like triggering something, switch on, switch off kind of thing. So like that, in Turtle Sim we have a clear service which is empty. So that means you don't need to like mention any request. Basically you have to do is row service call clear, then just pass an empty parenthesis. Okay, that's it. Okay, so if you do this, then the service will trigger. Okay, and it will execute. Okay, that's it. So if you do it, you can see what happened. The pen actually, the drawing actually got cleared, right? So if you do this again, yeah, it will again clear. Okay, so nothing is in the background. Okay, so I'm just again drawing it. Okay, and then I'm just clearing it. Okay, so basically clear will clear the drawings. Okay, and what about the kill? Not kill, the reset. Okay, so in order to understand the type of row service, we can use row service info reset, and then that is also an empty service. Okay, so you can simply use reset, okay, and then press enter. So now what happened? The robot got reset to the center, and then the robot visualization also changing. You can see the visualization, the robot looks also changed. Okay, so reset for resetting entire thing in the turtle sim. Okay, just like the looks when we start. Okay, and then we can see the set pen now. Okay, so row service info set pen. Okay, so basically the set pen, there is a service type called set pen. Okay, so you can able to check what is set pen is. You can use rows SRV, like rows message, rows MSG. You can use rows SRV, show turtle sim set pen, and you can see inside this service, this is a request. Okay, and there is no response from this service. So request, what are the requests? Red, green, blue, width and off. So this is actually the parameters of the pen. Okay, so this is the color of the pen, this is the width of the pen, and this is for enabling and disabling the pen. Okay, so in order to call this service, just use row service call, then turtle sim turtle one set pen, and press tab. So you can able to you will able to get these data, and you just want to fill it. So I'm just fill the red to 255 and width to 2. Okay, and off equal to 0. So off equal to 1 means it will disable it. Okay, so I'm just calling it. Okay, and now let's move. So you can see now the pen color turned to red. Okay, I can easily change it using the service again. Like I'm just giving the width as 10. Okay, and then and then moving it, so you can see the width again increased, right? Okay, maybe if you want to give a separate color, maybe I'm just giving blue as 100 and width as 20, and then I'm just moving, so like it's giving another color. Okay, so these kind of things you can easily do using services, like turning on, turning off. Okay, and if you want to reset it, just do the reset. Okay, it got reset. And then if you want to disable the pen, you can just make off as 1, and then if you just draw, there is no pen. Okay, so services are mostly like using for enabling and disabling. Okay, and yeah, so that's it. And now maybe we can see how to start another turtle using service. Okay, so let's see another service called spawn. Okay, spawn means creating a new one. Okay, so row service info spawn. So it is having a service type called spawn. So simply if you want to call it, call spawn, then you will get the data, and this is the location where you are spawning the new turtle. So I'm giving 55, and then I can give a name as well. So I'm just giving the new turtle name as Lentin, and then yes, there is new turtle, and you can see the new turtle, right? And if you just check the rows topic list, okay, you can able to see lengthen command velocity, lengthen color sensor, and lengthen pose. Okay, and if you if you publish to lengthen command velocity, okay, we can see what is happening. So I'm just changing turtle1 to lengthen, and you can see lengthen is actually start working. Okay, I'm just giving 0.5. Okay, and this is also working. Okay, so there are two command velocity and there are two robots. Okay, so you can create any number of robots in the turtle sim. So I just want to show you an example of a turtle sim application that is done by the last course members. So that is actually very interesting. I actually given some part of the code to him, but he actually made it in a very good shape, I will say. So the Iron Man drawing, I hope you have seen it. So this is using turtle sim. Okay, these are just for fun, but you will understand the ROS concept much better. Okay, so these are the type of project that we are starting with, okay, initially. Then once you are comfortable with the ROS topics, ROS service and all, we will jump into the real robotic project. Maybe first we will start with some simulation and then the real project. Okay, so don't think like why I am not suggesting to start with project. Why? Because we didn't discuss the fundamentals of ROS. Okay, only after this we can start projects. Okay, so please be patient. I can give you project ideas, and also like you can also suggest some project idea, then you can implement and publish. Okay, so the project was like you can give any image, and then the turtle will draw its caricature like that. Okay, so here we have given Iron Man, and then a swarm of turtle is drawing Iron Man. Okay, so actually it's not a robotic thing. Robotic thing means here you can able to see the turtle is not it's moving backwards, moving in y direction. So this is not how the robot moves, but it is actually doing by a hack in turtle sim. I can show you how to move turtle like this. Okay, so we can't use this program to move the real robot like this. We have to use another one, but this is like a turtle sim thing. Okay, but still it's a place to learn. Okay, so and there are turtle sim snake demos. Yeah, yes. So so let me just close this, and I'm just resetting. Let me reset. Okay, so when we reset, then only one turtle will be showing, and I just want to show the next one, that is Teleop Absolute. Okay, so this service was actually used for moving the robot in XY direction, but this is actually just for just for demonstration, I will say. The robot can't move like this. Basically how it works is that if you give a XY coordinate, the robot will go to there. Okay, so if I'm giving 1x, then the robot will go to there, and it will also draw the line. Okay, you can disable if you want. Okay, so this is how we actually draw the Iron Man. Okay, see, so you can simply move the robot in different poses. Okay, Yes. So this is not how the robot works, but you can see the simple techniques in TurtleSim, and this is for just for demonstrating the row services. Okay, if I just put y equal to 10, you can see the robot jump into this. Okay, and if I put to 5, okay, so that is absolute, and there is a relative pose as well. It is also for teleoperation, I mean teleporting. So these are the kind of stuff available with row services in TurtleSim. Okay, so you can think like what are the funny project that you can do with this. Make sure you learn the stuff. Okay, it's not for wasting your time, it's for learning how the rows communication works, especially the topic, service, parameter, all those stuff. Okay, so now we can see the parameters, and then we can jump into workspace and packages. Okay, so parameters, as I mentioned, parameters are like global variables or something like that, like that variables can access by all the nodes. Okay, if it is public, if that parameters are private, then only one node can access it. Okay, so let me check what are the parameters that TurtleSim is expecting. Okay, so you can use rows param, okay, space list. Okay, so it will be listing what are the parameters that TurtleSim set. Okay, so we have background B, G, R. Basically, using the parameter, we can set the background of the TurtleSim simulator. Okay, what you can do is you can use rows param command line, and in rows param you can able to set a parameter, get a parameter, load parameter from a file, dump the current parameters to a file, delete and list. Okay, so I'm just going to set a parameter called TurtleSim background B, okay, that is blue, basically to 0. Okay, and then I'm just resetting. Okay, so what happened? When we reset, the TurtleSim will be reading this parameter. Okay, currently the blue is 0, so it will have green and red. Okay, so what happened if I put the green to 0 and red to 0? Okay, and if I reset, possibly we will get black, right? Yes, it's black. Okay, and what happened if we put everything as 255? Maximum is 255 for any color. So 255, red, green, 255, and then if we set, red, green. Okay, I didn't set the blue. I need to set the blue to 255, and then if I reset, it is white. Okay, so these are some of the things that we can do, and it's white now, right? So let me check the topic called Turtle1 color sensor. I have seen there are some problems with the color sensor, but let's see. Yeah, see, the color sensor is echoing the color on the background. Okay, and if I change the color, for example, red to 0, and if I reset, it will take some time to use to this command for sure, but you can simply watch and understand. So see, you can see the color, the red to 0, right? So that value is reflecting here. Okay, so if I'm just changing blue to 0, and after that we have to reset, and then you can see the blue and red is 0 now. Okay, so the color sensor is actually detecting it and giving the feedback. Okay, so this is what the TurtleSim is, and I just almost taken the basics of TurtleSim because you are going to do the projects, maybe the initial projects using the TurtleSim. Okay, so I hope you have some understanding about turtle sim. So let me know if you have any question regarding the turtle sim. Okay, if you have any question regarding the turtle sim. Any question, guys, regarding the turtle sim? Yep. uh Anyone? Yeah. Yeah, yeah, got it. Yeah, so the thing is that uh, heads means the rate at which the data is publishing. Okay, for example, I am going to publish a topic. Okay, maybe you can visually check it. First, I am just starting ROSCO, then using ROS topic pub, I am just publishing a topic called test, which is basically string, and then I'm giving the data as hello. Okay, and the rate is 1 hertz. Okay, and then I'm just echo the test. So you can see the rate at which the data is publishing is 1 hertz. Okay, I mean the data sending is like one data per second. Okay, so but the problem is that if you are publishing a sensor data, for example, if you are publishing at a rate of 1 hertz, then that is too slow because the updation rate is too slow. For example, if it is an IMU data, IMU, or like imagine if it is a camera, okay, then 1 frame per second will be too slow, right? So if you increase the rate of publishing, then what happening is that we will get the latest value, I mean very quickly in the subscriber. Okay, so for some sensor we need the data very quickly because the change will be very fast. Okay, for some sensor the change will be very slow, so for that kind of sensor we need to we can publish it in 1 hertz because some kind of sensor like point cloud data and all, if we publish at 10 hertz, even one data will cost around I mean 5 MB. Okay, so if you send 5 MB data 10 times, okay, then it is like 50 MB per second, and that will actually a headache in the bandwidth. Okay, so it will take a lot of computation, and then yeah, so some data has to publish at low rate, some data this kind of text data we can publish at 10 hertz or like 100 hertz, no problem, based on the requirement basically. Okay, is that clear, Rishi? Okay. Yeah, I mean, using, I mean, even if it is geometry message or standard message, any type of message, it is, I mean, the syntax is actually same. Rows topic pub, then the topic name, then the kind of rows message, and then the data inside. Maybe I can show you the um, command velocity. So I'm just publishing, I'm going to publish geometry message twist. Okay, and inside the twist, if you just give a space and press the tab, you can see this much of data. Okay, this is the content of twist message. Okay, this much of data is going through twist message. So if you send a twist message, that means you are sending 6 field, actually 6 data, so 6 data simultaneously. So if I give linear to 1 and angular to 1 again, and then You can publish it in any rate, like 10 heads or 1 heads. I'm just giving 1 heads now, and then if you echo the test, you can able to see this twist message. Okay, so the difference is, like, if you have different rows messages, like for simple messages like string, then integer, you can simply mention the data. But for the big rows message, you have to like fill the data in that template. Okay, then only it will publish. There is a template. I mean, this is a message definition. In order to get the message definition, you can simply search. You will get what are the things inside this message. You can see inside the twist message there is vector 3 and vector 3. I mean, vector 3 linear and vector 3 angular. Vector 3 means there are 3 float variable. So vector 3 is again another message. So we can use another message in I mean, different messages inside another message. I mean, what I try to say is that here we have the twist, and inside the twist there is another message called vector 3. Okay, so we can use a message inside another message. Yeah, so yeah, you have to fill this value and then publish. Yeah. Yep. Any confusion, Urvashi? Okay. Yeah, and these things comes I mean, easy when you practice. I understand that this you may can't follow my commands because it will take some time to do this and practice. Okay, so yeah. So any more question, guys? Any more questions? Okay, so if you have any question, you can either post it in Discord. Yeah, there is a question. How to move the turtle board in the following way: 1. Set the origin. 2. Start to move to zigzag position. 3. And come back to origin. How to do it in it? Yeah, so this is purely logic. So first, how to set the origin? Okay, so we can set the origin using either using the service. Okay, the default origin is actually 5.5, but you can override it in the launch file. Okay, when you spawn the turtle, you can just mention the origin as well. Okay, so like maybe I can just show you turtle sim. Yeah, so origin can be set either in the launch file or using service. Let me check, is there any tutorial regarding that? Multisim. Okay. Yeah, basically I think we can able to set it. Maybe if I get any tutorial, I mean, many tutorials are there. These projects are open source, and you can find the code from the GitHub. Maybe I can share this link, so you can just go through each project and see how these things structured. And in order to move in zigzag position, it's again easy. Like, you can rotate the robot and move in the straight line, and there is a project like zigzag movement. Yeah, so you can see a turtle sim project. It's basically a zigzag movement. Okay, and there is the GitHub project is also there. Okay, so you can check it. So basically, using these services, using this topic, you can basically move the robot in any fashion. Okay, and for getting the feedback, we are getting the pose, right? So imagine we started from 2, 2. Okay, so we know the pose. starting pose, and we know the feedback. Okay, and whenever you move the robot, we know where it is, what is the pose of the robot. Okay, so that's in that way you can do it. Okay, and there is another concepts coming, which is TF. Okay, so using TF also we can draw, you can create some interesting applications. Okay, 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 if that is clear, then I think we can start with the second chapter next week, like workspace, CPP. So make sure these concepts are very clear to you. Okay, then for me it's very easy to explain all these things, the programming aspect. Okay, so I will be uploading today's video, maybe today itself night I will be uploading. And if you are clear with the ROS command line tools, then the computation graph, RQT, RVs, all this stuff, then from the second chapter I can easily explain without repeating the stuff. Okay, so this week just take some time to go through the ROS basics, okay, concepts, and command line tools, and all the stuff. And then from next week I hope we can able to start programming, and maybe we can complete the next chapter as well. Okay, maybe I can equip with some example programs so we can quickly cover this. Okay, so can we conclude then? Okay, so we can discuss the second chapter next week, mostly next I think next week again I have a workshop, but let's see, I will announce a time. It may be on Friday, or maybe only on Sunday. I will announce, because these kind of workshop I have committed last year and it was online at that time, but now most of the colleges are like in offline mode, and they are asking me to go to that location and take on-site classes. So that is actually the problem. Anyway, I will announce the time, okay, next week. Okay then guys, thanks for attending. If you have any question, let me know. Okay, don't hesitate to ask doubts. Okay, and because this is an important chapter. Okay, this is a fundamental foundation of ROS 1, and it's also the fundamentals or foundation for the ROS 2 as well. Okay, the same concept we are using for ROS 2. So okay then, thanks for attending. Good night and see you next week. Bye everyone.